Testing 1 2 3. I'm gonna adjust my mic volume this time because I feel like it wasn't loud enough before. I feel like it wasn't loud enough before. We're in go hell. Give me a second here. We're in somehow we've not muted that. Okay, cool. Give me a second here. Oops. If that ends up being too loud, let me know. Okay. Let's check my levels here. Seems okay. I'm not going to the red, so should be good. Okay. Yeah, so last time basically, let me look at our diff real quick. What was working on? What do we do here? Oh, we did some work on the game simulation here. Just setting up like permanent game data. I'm gonna commit some of this stuff soon. I don't want to go commit it as is though. What do we do? Yeah, we did some allocation stuff. I just adjusted some stuff for testing. Oh yeah, we did the okay. Hold on, let me just do this real quick. Commit this real quick. And yeah, we added this character data file, which has hitboxes and hitbox group. Hitbox group just being a range of frames that we're gonna actually check hitboxes. Okay. So this hitbox structure is actually going to be used both for our runtime. Well, for now, it's going to be used just for our runtime. We'll have like a stored hitbox data structure later, but that's what not really what I want to talk about this time. Well, not directly anyway. This time I want to implement a collision system. Yeah. So, or was it? Oh, I don't want to look at here. I want to look at this wrong thing. I want to look at our planning document. So basically, I'm going to start working on the collision system this time, which is actually going to do the check to see if hitboxes overlap. And we might make a new runtime structure for storing hitboxes. I don't know if we get to that, but it's going to be based on what our how we're actually executing the code, right? Okay. Well, I was going to get in on that, and I'll just start explaining. I guess with the archives, anybody who missed something can jump in. Let's see if anything's going on here. Everything looks good. Give a few more seconds for people to jump in. Okay. Anyway, so we're going to jump into our game simulation code real quick. We've already made a system before for like processing game state, right? We have the physics system which updates like velocity and position. Action system which handles our state transitions. We're going to make a new system, and actually for now, to reduce clutter in this file in particular, well, we'll break stuff out in a bit as another exercise. But yeah, let's make our new system. Let's call it the collision system for now. And of course, it's going to take in the game state, because it's going to need to modify the runtime data. So that's kind of our sketch for collision system. And the idea is eventually what we're going to do is at some point we're going to have like some function that's like is overlapping or something, and then we're going to take like hitbox A and hitbox B, right, or something like that, right? And we'll have something like, if it is overlapping, we'll return, if it is overlapping, we'll set some flag like, entity A dot hit opponent is true, which will just indicate that the well, let's just sketch it out here real quick, and then we'll write the real code, right? So the idea is, this is pseudocode, so please don't sue me. So at the lowest at the deepest level, we'll have like two hitboxes from entity A, entity B, and then we'll like do something like, this is conceptual still, right? So please, just keep that in mind. What's going on here? I'm going to say pseudocode here for a second. This is the idea, and then entity.b was hit by opponent. This is just conceptual stuff. Will equal true, and it'll something like to the A. Oh yeah, and then entity A dot the opponent or something like the hit opponent equals entity B, and then entity B hit by equals entity A. This is a conceptual code, right? And then we could like respond later on in the game, later on in our pipeline, we could respond to like these kind of events, right? This is not actually how we're going to write it, but this is conceptual. And actually, we'll have to go to like for all attack boxes in entity A. And then for all attack or all vulnerable boxes. So our character is going to have attack boxes and vulnerable boxes. Attack collision boxes will be the ones that can actually inflict or inflict the damage. Vulnerable boxes being the ones that can indicate whether or not an opponent can be damaged. Okay, all vulnerable boxes in entity B. So let's just say we have two characters, entity A and entity B, and so we have two characters, entity A and entity B. We see if check if entity A's attack boxes overlap entity B's vulnerable boxes, right? That's the idea. That's the conceptual part of this code. And then we'll loop through all entity A's boxes, and then we'll loop through all of entity B's boxes conceptually, right? And to check to see if the two boxes are overlapping, right? This is complete pseudocode. Okay, that's not actually how we're going to do it, but that's the idea. And then actually, the function is overlapping. We'll define it as is overlapping A, B. This is the pseudocode still. It's gonna be something like, this is just again pseudocode. So the idea is, if the two hitboxes are not overlapping, we can kind of do an early out. And I'll show you how. So for example, again pseudocode, if A's left or A's right side is greater than B's left side, then we can say they're not overlapping. Okay, so we can say just return false. And then if A's or if B's right side is greater than A's left side, then they're obviously, oops, wrong way. So if A's left side is greater than B's right side, that's correct, yeah. And then if B's left side is greater than A's right side, we return false. So it means you can conceptually see like this is would be A's left side. Oh my god. Hold on, yeah. Sorry. B's right side, A's left side. If these are here, they cannot be overlapping, right? Because the boxes would be here. I don't really have a good picture here. You can just visualize it like this. B, A, right? Conceptually. Okay, and then same with here. We have A, and then B. What's this cleaner here? Right? And then we have the other cases with the top and bottom, right? And we can, I'm just going to sketch it out here real quick, just for funsies, I guess. Oops. This horizontal space doesn't matter too much. It's not the best box, but oops. Just conceptually show this. A, oops, B. Okay, these are two hitboxes, A and B, top side, bottom side, right? And then we could pretty much copy this code, but change left and right to top and bottom. So conceptually we'd have, oops, if A's bottom is greater than B's top, then it's obviously, they can't be overlapping. And then if B's bottom is greater than A's top, then we're also not overlapping, right? So it means as soon as we hit a statement like this, we know it's not cannot possibly be true, then we could exit. And it's the same for each of these conditions. And otherwise, it must be true, right? It must be true that they're overlapping at this point. Because if it wasn't the case, one of these conditions would have been satisfied. I hope that makes sense. Okay, so we're going to write this in a much more concise way, this kind of pseudocode. So let's start it this way. That actually needs to be a void. So we're going to write a simple function for checking if two hitboxes are overlapping. So there's a few different ways we can do it. We could put it inside the structure itself. I'm not going to do that for now because this is going to be very localized to the system. So do hitboxes overlap is what I'm going to check here. Okay, and there's going to be a bool. We need two hitboxes, so it's going to have to be A. Whoops. Hitbox A, and then we got B hitbox, and we haven't included hitbox yet, so hold on. Where do we put our hitboxes? State machine, component, character data. So right now hitbox is in character data, okay? I think we've included that already, right? Yeah, so for now, I'm gonna say character data hitbox. We might change this up in the future. Probably will change it up in the future, right? So we can write this in a very much more concise way. We can just write in one line if A dot, start with here, A dot left is greater than B dot right, B dot right. So this is, for now, let's write it like this. Const is not overlapping. going to be equal to if either a dot left is greater than b dot right, or and honestly, let's go here to make things much more simple real quick. I want to go to Godbolt. We should have a little example code here right now. Just make sure everything compiles and works as we expect. So, we'll stick to here for now. Sorry, it's going to be much work than I thought. Okay, so if a dot left is greater than b dot right, or let's just put some parentheses around these. The next one obviously would be b dot left greater than a dot right, or what was the next one? A's bottom is greater than b's top. Yeah. A bottom is greater than b dot top, and then in reverse. B A. I want to do that. B A. So we could do something like that. Just to organize it. Can we quickly format this in a nice way? Nah, I think it's gonna crash the language server. Or basically, I think it crashed yesterday, but oh well. So if any of these statements are true, that means we're absolutely not overlapping, right? So it's going to exit, because of the or, it's going to exit out of this check almost immediately. So we can do, return. And the thing is, we want to turn not is not overlapping. So I know it's like double contradiction, or double negative, but hope you understand what I mean with this. So we can make this function a little less confusing, but this is the idea. Do the hitboxes overlap? Okay. So again, the same kind of check we had before, just to guarantee these things are not overlapping. So it's with only at max 4 checks, we can see if 2 hitboxes are overlapping. Not bad. If we go into like Godbolt though, which is what I wanted to do, let's go ahead and delete some of this test code I had before. Okay, right. So we're gonna make a function here. We don't have the hitboxes over here, but I'm just gonna delete this from here, and just go ahead and do, just for posterity's sake, hitbox equal to struct with these 4 parameters. You know, not a. Top, left. That's gonna be easier if we stick to the horizontal, vertical. So left, top, right, bottom. Okay. So we're hitbox here. Does it all compile? Actually, we need to get rid of this. So we don't need the comma there, I guess. So it takes a hitbox, does a comparison. I want to see the complexity of the assembly too. See what kind of stuff we get out. Oh, bottom there. And then let's make 2 hitboxes for hitbox A is going to equal a hitbox. Let's say left equals 100, top equals 200. Whoops. Top is equal to 200. Bottom is equal to I don't know, 0 on this one, and then oops, and then we just want to do left here, or right is equal to 300. Okay, and then we can make hitbox B. Oh, let's not make it vars, let's make it const actually. Okay, and we'll have, so we want to check if they're not overlapping for now, so let's do this. Let's make the left side greater than 300, so I just want to do 400 there for now. And then the right side needs to be greater than that, so it needs to be, let's just do 600, okay? So these have the same vertical height, and they're, and what is going on here? Okay, so then we'll do standard dot what was it? Standard dot debug. What is it? Standard dot debug dot print. That's it. Okay. Oops. We'll do this. Ooh, go in here. Where do we go? Okay. Standard dot debug dot print. We need to do so. We're just gonna do really simple here. Make an empty argument list here. Okay. And we're going to do this just for simplicity's sake. If do hitboxes overlap, we're going to say hitbox A and hitbox B. Do this one, else the other one, right? So, oops. Okay. Compilation failed. Oh, 29. What did it do? 29. I'm going to mess up here. Oh, I'm missing a parentheses. Okay. Error, expected type found bool. 13, what did I do here? Expected error set type found bool. Really? You can this can actually be an error? Oh, this merges error sets or performs Boolean or. Oh, okay. I forgot about that. Oops. Okay, let's do it. Or makes sense. So this turned into an error set type because of the special operator. C habits. Okay. So where's the actual core of our code? It seems like there's a lot of code generated. Oh, so we have some array stuff for some reason in here. Okay, here's our hitbox overlap code. That's what we're looking for. Okay. What's going on here? We have a few copies. We have a test here that jumps to here. Okay, this is so basically we have a test that jumps to here. We have a test that jumps to here. We have a test that jumps to here. So how many jumps do we have here? Like 1, 2. This is jump not equal, by the way. So basically it jumps to this code line here. So these are basically our tests, right? So it does a test with the AL register against 1 here. Oh, okay, sorry. And it's going to compare the, whatever is at RSI plus 8. And RSI is assigned, I think that is the, what's passed over as a parameter as a function. I think that's correct. It's pushed onto the stack. Yeah, stack in I is a stack index register, I think. But yeah, it's plus 8. What was plus 8? It's probably, well, these should be 4-byte integers, so it would be the right here. What do we check first? We check left and right, so that kind of makes sense. So we compare it what's in EX with this. What do we RDI? So we push RDI. What is an RDI? It must be left, right? I'm not entirely brushed up on my assembly, but we can kind of see what it builds down to. So if you really wanted to see, if we want to check how many like cycles or whatever this took on the CPU, you could go through here and do some back of the paper math. Well, anyway, it looks like that, as far as I'm aware, that works. Interesting, we didn't get any output, though. Why didn't we get any output? Did it not execute? This is compiler. Oh, execute the code. Okay, here we go. Okay, let's just do some tests here to see everything works as we expect. Not overlapping. Cool, that makes sense because our left side here is greater than the right side on this side. If we make this 150, though, they should be overlapping. Give it a second here to build. Okay, is overlapping. Okay, great. So we could do a test for all these, but I'm just going to assume for now that it's working. And copy the code back over here so we're actually using OR. So yeah, we're just going to leave the code as do hitbox overlap. Okay, check to see if two hitboxes overlap. Well, that's obvious. So, okay, so we have our hitbox function that does something like that. So we're going to know it eventually. We're going to have to call this, right? The other big thing we need to talk about is actually we need to transform hitboxes to the same space, right? Hitboxes are going to be stored not in the actual. We're not going to be updating the hitbox positions, right? The left and right, the top and the bottom, every single frame for every single hitbox. What we need to do is to transform them right before we actually check their position. So yeah. So we're going to have to transform the hitboxes. Let's just go ahead and write a function that does that. So it's going to have to, we know it's going to have to take a hitbox. And we know, let's just say, yeah, it's going to have to return a hitbox. Okay. And basically we're going to return a new hitbox that's been transformed. So, oh, we need to transform though. So let's use a vector, our 2D vector as an input format. Okay, or we just X and Y. Doesn't really matter so much. Let's just say vector for now. We can add an XY version later if we need it. Okay. Let's say instead of transform hitbox, let's do offset transform, because transform generally means it can be rotated, blah 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 blah. Well, since we're taking 2D vector, we can assume, let's just say move hitbox. Let's call it move hitbox for now. And this will be the offset. And then we'll have basically, we'll just take, make a new hitbox where the left is going to be equal to the hitbox.left plus the offset.x. And then right will be the same, but with right. Make sense? Let's just organize this a little bit more. And then we need top and bottom. So dot top equals a hitbox dot top plus offset dot y. This would be more concise if we store the top left, bottom right in vectors, but yeah. For this game, all our hitboxes are axis aligned 2D hitboxes. That means we could do this kind of work. Hey, how's it going, Aussie Mandian? Thanks for dropping by. Alrighty. And then the bottom will be, obviously this is not right, top, yeah, that's right. So this needs to be bottom. Okay. This does not need to be a colon, it needs to be, let's just align everything here so it's easier to read. Okay. Could do that. It feels a little anal though. So we get the bottom offset by Y, right offset by X, top offset by Y, left offset by X. So this is going to transform our hitboxes into whatever space we need it to be in. In our case, it's going to be the position of the character. So we have our overlapping function and our move hitbox function. Oh, not move. This is called translate. Okay, cool. Translate hitbox. That's the word I was looking for. Okay. There we go. We have our new hitbox translated. Translated just means moving, basically. Anyway, here we go. So we have these two important functions, utility functions. We're still not quite there, though. We have the ability to check hitboxes, move hitboxes. So we're going to have to, like, go through all hitboxes, translate the ones we want to work in. One way we could do it, just to think conceptually, right? We had all this pseudo code down here. We're going to ignore that for now. Once we loop over everything, we would have to say, like, it would be something like translated box A equals translate box A. Okay. Box A, and maybe something like entity dot position. This is, again, this is pseudocode, so don't think too much about that. Just trying to put things in a conceptual framework first. So translated box B will be obviously the same kind of thing. We take hitbox B and entity B dot position. Just thinking ahead here, and then we'd obviously then we'd do like let's move this down here. So we check to see if two hitboxes overlap. You know, do they? Okay. Obviously something like this. Translated box A, translated box B. So that's actually what we want to do, right? And then we'll, like, you know, obviously assign. That's conceptually what we're going to do on the hitbox to hitbox level. So we could make these big for loops that go through all the hitboxes, translate them each time, and then actually do the overlap like we're doing here at the very deepest level of the loop. Another way you could do it is generate a whole set of new hitboxes, right? Translate them ahead of time, and then loop over them, the new hitboxes. Why would you do that? Well, one way, if you have a lot of hitboxes you need to check between a lot of entities, you don't want to have to retranslate them for every single entity, right, that you're checking. that kind of optimization is not going to be that necessary right now. We might run to a situation like, one of the reasons I picked this kind of design for this game, the what was it, IAMP, or the immaterial missing power, is because it has a lot of projectiles. And because of that, we might be doing a lot of collision checking. It gives us kind of motivation to optimize our collision system. Just something to keep in mind. For now, I'm going to do the simplest case, and we'll come back and reorganize the stuff to be more efficient if our profiling shows that it's not performant, right? Okay. Anyway, that's just something to keep in mind. So right now, we don't actually have characters with hitbox data that we want to loop over to actually do this kind of stuff, right? And we're going to need a set of flags to indicate when a character got hit. And then we're going to have to respond to the hit by adding things like hit stop, assigning reactions. So all kinds of stuff that comes off of doing the collision checking, right? Our collision system. Our collision system is not going to be in charge of actually handling reactions or things like hit stop. The reason for that is we're going to have another stage, in which we've already seen the stage. It's in the what is it? Our state machine system. When you have a hit occur, you need to have a state transition from whatever the character is currently in, either attack or idle, whatever, into the reaction, and that's going to have to go through the state system. Again, think a little bit ahead here, because I've worked on games that have done things different ways. One way you can handle it is you have the state system update. Let me go to that real quick. State machine component. No. Okay, we have it under the action system. But yeah, the state machine gets updated here. We could force the game to only allow one state change, right? A frame, which is conceptually simpler. We could think of only one thing occurred this frame. It lets us avoid certain kinds of bugs. So that would mean we'd have to have the collision system execute before the action system. If we go to, where was our documentation? Technical design. Where was that at? Code architecture. Okay, so an original design here, we had our action state machine update happen at the very top, and then we had collision at the bottom, or after that, right? Where was it? Attack collision, almost the very bottom. So what would this would result in is this attack collision having to store data for the next frame, and then would add 1 frame delay to any collision. And actually, you've probably seen this in fighting games if you've really stepped through them before. If you turn like debugger, you can see a collision box overlap a character 1 frame, and then it will cause a reaction the next frame. What happens when 2 hitboxes collide with a hurt box on the same frame? So it depends on what the hitbox is from, right? Let's just refer to them as attack boxes and vulnerable boxes, just to be clear. So if 2 attack boxes collide and if both attack boxes from the same character, we don't really care that much. We're just going to check for the first one. In our game, in our design, hitboxes won't have different properties. They'll all share the same attack properties, so we only need to check for the first one that hits. Now, if there's multiple characters or projectiles which have different kind of properties, we're going to have to prioritize the hit, right? And generally in fighting games, you will only take the hit from one thing at a time. Now, this isn't something that has to be the case, right? This is just a general. It's been a kind of consistent thing that's been a consistent way collisions have been handled in fighting games. You could think of other ways, right? You could say, oh, let's add the velocity on the pushback on all the hits that frame, right? But you can see the kind of bugs that could easily pop up from that. So it's just simpler to apply one property in one frame. Another thing you could do is take the hit from the first thing, and then the next frame, take the hit from the second thing, right? And maybe you prioritize character attacks over projectile attacks, vice versa. This is kind of actually how unblockables happen, right? If you know anything about Guilty Gear, in the old games, Zato, who's the character, has a shadow, and the shadow can attack with a low attack, and Zato can jump in the air and attack with a jumping attack, which gives it a high. Yeah. The truth is, the way they're implemented, though, they're not really truly the same frame unblockable. It will alternate between low and high, depending on the timing. Effectively unblockable, just because it's inhumanly. I think not only do you have to guess, you have to guess what hits first, and I don't actually know how things end up being prioritized, because I don't think it's actually the same every time. Hard to blockable basically means impractical to block, right? Yeah, it means you're not blocking it. Just switching block within one frame is inhuman, right? It is beyond human level. Anyway, you might get incredibly lucky and land on the right frame. But yeah, so just going back on what I was saying before, if we update the state machine first and then do character attack collisions, not only do we have to store the collision trigger, the event, for the next frame, but it also means the effect of that collision cannot be processed until the next frame, which means we get a 1 frame delay on collisions. This doesn't, as far as like, how do we put it, the overall effect of it doesn't really matter that much, because generally in fighting games, when one character hits another character, you get something called hit stop, right? So both characters pause for a fixed number of frames, and then you go to hit stop, and then you both go through your recovery. The attacker goes through the animation that's at the end of their move, and the receivee of the attack, they go through their recovery frames and hit stun, and that's how you end up with things like frame advantage. So ultimately, this decision does not affect frame advantage unless you mess it up. You just got to make sure the hit stop is applied equally on the next frame, right? The other way we could do it, conceptually, is we could run all the attack collision up before. We could run it before the state machine. That means this frame, when we detect a collision, this frame, the attack, will transition into reaction, and you make sure that on this frame hit stop starts, right? But there is a caveat to this. State machine executing after means there's a 1 frame latency from the state machine update until attack collision check. So if, say, this frame, the state machine updates and you see a collision box overlapping on that frame, like if you're just stepping through with a debugger, you won't see the collision until the next frame. So we still get a 1 frame latency, right? Either way, we get a frame latency. It's just how we're going to handle it. Come on here. But there's another option, actually. We can have 2 stages. We can update our state machine, do the collision to check any collision that updated this frame, and then handle reactions afterwards. So it's basically we do 2 state machine updates, one specifically just for reactions that deals with the effects of a collision. This would remove the latency, right? It does add a level of complexity and potential bugs. It's no longer a simple one stage up. Previously, we could just look at the state machine update in one place, and and find all the code. But then we have it split over 2 potential stages. Every time you add multiple places in code that are effectively doing the same thing, you can run into bugs, right? If we need to change something for the state machine update and didn't change it for the reaction system, we can like end up with like a gameplay contradiction and bugs. So that's something you have to keep in mind. I've chosen to organize it in this way, right? This is how I do it in a lot of my modern games now. I did it the other way in the past where I had like one location in code where you did a state machine update. But I realized there's a lot of extra complexity, right? You have to keep persistent data between frames for collision. For all your collision events have to be stored between frames for one method, and the other obviously introduces latency. Now, I've seen games that do the thing where it introduces 1 frame latency, so you do see a hitbox overlapping 1 frame, and then the hit actually happens on another. It doesn't really matter how you do it as far as like gameplay. What at the end of the day, what gameplay wise goes, like, is that 1 frame latency that bad? Like, what does it actually have? How does it actually affect the player? When you have 2 characters, it doesn't make much of a difference. When you start introducing projectiles, though, it can have very subtle differences, right? A projectile can keep moving while the 2 characters are hit stop and hit the player, right? So I know this is something to keep in mind, but I've just chosen for this project to go with this method. We're going to have a state machine update, which will update the current frame and everything of the character animation and such. And then we'll do collisions to handle any hitboxes that have become active through the state machine update, and then deal with the reactions. The other benefit of this, and one reason I chose this, is I can actually generate collision events here that are then consumed by the reaction system, and then I don't have to deal with that data anymore, right? I can just generate some events. I know the reaction system is going to be able to consume it this frame, and then I can just throw that event away. I don't have to store that data. What does this actually matter? Well, we intend to implement rollbacks, right? And any persistent data between frames needs to be stored for rollbacks because they are the input into the game simulation to generate the next frame. Anything that affects the next frame needs to be stored for rollbacks. That's the idea. How are we looking here time-wise? We have 10 more minutes. Might chat a little bit more. I don't know if I want to code a lot more today. I just wanted to go over those decisions. I just want to put down on paper video the reasoning for that stuff. This is some of those like important fighting game design decisions that are not really written down anywhere, but it's something you have to be aware of when you're making these kind of games. Yeah. So just again, the attack collisions will generate things for the reaction system. Now, there's going to be other subtle latencies that get introduced that might carry over to the next frame. Things like, pushback and velocity stuff will be carried over to the next frame or the future frames. But that's fine because during hit stop, there will be no pushback, right? So this is open source. So you can go grab the current updated source code from here. It's in progress. Keep in mind, but it should be buildable if you have if you at least followed the early videos on how I set up the Zig stuff. Yeah. But yeah, it is a proof of concept of making something in Zig, but also more of a educational, and I'm making it for documenting, or to keep this information out there in the public, because it is kind of like institutional knowledge that is not really written down anywhere. Because I previously worked on several fighting games, including Killer Instinct, my game Fearless Knight. I had worked on Squirrel Girls in the past. Also knew Guilty Gear before that. But yeah, just getting this information out there is important to me. I want to like write it down. My memory is not going to last forever. So yeah, just for those purposes. Yeah. Okay. So I just want to think a little bit about what I'm going to do next time. Uh, These streams are not necessarily that long or long enough to do a lot of deep programming, but I think having them in these little chunks is helpful for people who watch them later, right? Okay, what do we got here? Yeah, so today we made changes to game simulation, of course. We have all this pseudocode that we showed. I'm going to get rid of this at a certain point because I was just using it for demonstration purposes. Yeah, so next time, we really need to make a decision on how we're going to store the hitboxes per character, because if we're going to really start testing this game-wise, we need to have a persistent store of all the hitboxes per animation, per character. We have states right now. We don't have any data associated with those states. So we're going to need something like a timeline. And on that timeline, there will be events, the major one being hitboxes. So the hitboxes will be conceptually on that timeline for a fixed number of frames. That's why I put them go into here. That's why I made this hitbox group with start and frame and duration. Oh, thank you, Ozymandian. I'm glad you get something out of it. It's good to hear that it's interesting for somebody. I'm always not quite so sure about that myself. But yeah, so I think next time what would be good to go over? Let's just go ahead and write that down. So let's implement. So our timeline data structure is going to store the events such as hitboxes and things like that. And during our action statement or action system, we're going to update that timeline. And then other systems can read the current frame on that timeline to see which data is active. Okay, such as hitboxes, such as animation frames. I think that's the way to go next time. And yeah, if there's any other questions about that or anything else, or you just want to chat and bring anything up, general discussion, anything's great. I'm going to chill out here for a second, just see if anybody has anything they want to bring up. Otherwise, I'll head out here in about 5 minutes at the most. Okay. So I actually didn't get to this. Let's put it there for now. I think one useful thing coming out of this project too. Oh, well, thank you, Ozymandian, for coming by. It's really important to me that people are here to actually interact and make this a two-way interaction, not just a one-way lecture kind of thing. But yeah, I think the good thing coming out of this is having things in 1 hour chunks. Is I'm able to like put more time into thinking about this stuff. The coding part isn't that essential, right? But the reasons behind all the decisions and going through as deeply as possible into the decision-making processes, I think that is what's actually important about software development, not the coding part. You know, I could sit here all day and write code straight from my brain because I have a lot of experience doing this stuff. So I could just like, you know, intuitively write a lot of this stuff without even thinking about it. But what is the point of watching a video of someone just coding? I guess I just don't see a lot of value in that. I've seen some of those streams. We didn't actually write that much code today, but I was able to go through step by step how we end up in writing the code that we do, right? Yeah. Basically just that. It's about 10:30 here a.m. in my time. I know it's going to be pretty late for a lot of people out there in the U.S. or in definitely Europe. It's I don't even want to think about it. But yeah, if there's nothing else, no any other questions. Again, as always, I appreciate it. Everybody's dropped by, and big thanks to everybody who interacted in the chat. And yeah, I really hope you all drop on by again. For y'all who are going to bed, good night. For y'all waking up, good morning. I got to head out. Peace. Hope to see you all very soon. Bye.